The exponential function is given by this formula, and it means the powers of a number e, which is one of the most important numbers in math. Similar to pi, it is an irrational and transcendental number, and is close to 2.71828, and it goes. It was named after a mathematician called Euler, which appeared on the 10 Swiss franc, and it can be motivated as a way to calculate instant interest. I am Alfonso, doctor in pure math, learning statistics, and I will explain here the number e and the exponential function. The number e can be defined as the formula here, and what this formula means is that substituting the number n for 1, 2, 3, 4, 5, and so on, we start to notice first that it starts in 2, then we go to 1 plus 1/4. These numbers are increasing, and every number here will be below the number 3. So we can expect that this is getting closer and closer to a certain number. That number is the number e. We can see here on Python the values when n is equal to very big numbers, and also we notice that it's getting closer and closer to the number 2.718 and so on, which is the number e. How this number started and why it is related to the instant interest of a bank. Well, for that, let me tell you the following story. Imagine there is a very generous bank which gives you 100% of interest. After 1 year, then we will have double what we started with. Now it appears a more generous bank, a generous divided by 2 power 2 bank, which gives you half your interest but 2 times per year, in half a year. Then, after 6 months, we will have this amount of money, and after 1 year, we will have this amount of money. This process can be repeated for n times, so we will have a generous divided by n power n bank, which will give us 1/n of interest in 1/n of a year. Then, after a year, we have this amount of money. And if we go making the process until infinity, then we will have that after a year, we get the number e times what we started with. But most banks are not that generous. Most banks give you an interest of, let's say, a number p. In that case, after 1 year, we will have what we had before plus the interest. And if we do the process, now we have a normal divided by 2 power 2 bank, then we will have this amount after 1 year. We repeat the process again, and we have normal divided by n power n bank, which after 1 year will give us this. And if we repeat this process until infinity, we will have the following formula. But what does this mean, this limit, when we knew the limit when instead of here having p, we have 1. Now that we have p, how can we calculate this limit? So let me show you this, how I do this, and we get exactly the exponential of p. From another point of view, when I was in the university, the first time I saw the exponential was given using this other formula. And with this other formula, it's really easy to see that the derivative of the exponential is equal to the exponential. Now, how do we see the relation between this formula that was given in my university at the beginning with the formula we just saw previously? For that, let me write this. We will use the Newton's binomial to calculate this part. We get this big sum, but we also notice that this part will tend to 1 when n tends to infinity. Therefore, we get what we started with. As a summary, we just saw that the interest of the normal divided by infinity power infinity bank is equal to this limit here, which also is equal to the exponential of p, and which also is equal to this sum. And that the derivative of the exponential of p is equal to the exponential of p. Now that we got enough exp, we are ready to take over the Poisson distribution. So see you later, Pokemon Trainer.